This video is going to explain how we do our insurance calculation for rate making and our adjustments. So the question we're asked to solve, suppose there's a 10% chance you wreck your $20,000 car this year. If you wreck the car, it is a complete loss. Your current wealth is $40,000, and there's a 90% chance that you have no car wreck and therefore no loss whatsoever. So question A asks you to find the actuarially fair insurance. Actuarially fair insurance means that the insurance company makes no profit. In other words, the premium they receive is equal to the expected cost that they would pay out. So there's a 10% chance they'll have to cover your car in full for $20,000 and a 90% chance they'll pay nothing. So their expected cost is $2,000, so that's the actuarially fair premium. Then the next part of the question asks you to play around with a person's utility. So you're given a utility function, their utility of wealth. The utility function takes the shape, takes this form, so the square root of their wealth. So the first part asks us to calculate the wealth without insurance. So if they don't have insurance, there's a 10% chance that they'll figure out the utility of wealth with a loss. So that would be $40,000 minus the $20,000 loss. Plus, there's a 90% chance they would receive their utility of wealth without any loss. So a 90% chance they would receive that $40,000 or maintain that $40,000. So then we plug into the wealth function, or the utility function, which is the square root of the wealth. So 10% times the square root of 20,000, or 40,000 minus 20,000. Plus 0.9 times the square root of 40,000. So we come up with an expected utility without insurance of 194 and 14. Then if they have insurance and they use actuarially fair insurance, meaning they pay a $2,000 premium, then how does that work? So it would be the utility of wealth with a loss plus the coverage. So we would have the $40,000 minus $20,000 for the loss, plus if we have full coverage, it would be a full coverage amount. So you receive back the $20,000 minus the $2,000 that they paid for the premium. So this is what happens in the event of a loss, and there was a 10% chance of a loss, and our utility function is the square root of wealth. So we plug all that in there, and then for without a loss, there's a 90% chance there's no loss, in which case your wealth is 40,000 minus the 2,000 you paid for insurance. Again, plug into the utility function. So when we solve, you come up with 194 and 93 cents, which is higher, right? Not that much higher, but so we realize that even with paying $2,000, your utility with your utility with insurance is higher. This is because a risk-averse person will always choose to fully insure. Okay, so then the next thing we do was move on from just the econ side to now looking at the rate-making function. So calculate the gross premium based on the pure premium methodology if the insurance company faces variable expenses of 15% and targets a 3.5% profit on any policy it underwrites. All right, so remember the actuarially fair cost of insurance, or gross premium, pure premium up here, losses divided by exposure or frequency times severity, or expected payout. Remember, that was $2,000. So we're going to go over here to use this gross premium adjustment. We don't have any fixed expenditures to add on, but this says the numerator is pure premium plus any fixed expenditures, which are not listed in this case, divided by the quantity 1 minus variable expenditures as a percent minus percent of profit. So I go down here and I apply that. So my pure premium was 2,000 divided by 1 minus 15% for variable expenditures minus 3.5% for profit. So instead of being 2,000, what they actually would charge is $2,453.99. Okay. The next part talks about how we would make an adjustment to that based on actual losses. So we will go down here. In Part D, calculate the expected loss ratio implied by the gross rates calculated above. Assume that the firm underwrites 15,000 policies. So if they underwrite 15,000 policies and they charge $2,453.99 on each policy, then they would receive $36,809,815.95 in premiums. Their expected payout would be $2,000 on each of those 15,000 policies. So therefore, their expected payouts or losses would be $30 million. So the expected loss ratio would be the payouts divided by the premiums. And this you can see is from, let me scroll right up here, make sure you see that you have that formula. So the loss ratio, losses divided by premiums. Okay, and the next thing we're going to do is do the adjustment to that, which is actual minus expected divided by expected. So my expected loss ratio is 0.815. Okay, or 81.5%. Now, let's look over here. Let's say the actual loss ratio is 0.83, so I need to do the adjustment. Actual minus expected divided by expected. I plug that in. My actual 0.83 minus my expected 0.815 divided by my expected 0.815 gives me 0.0184. I can move this over that says increase your premium by 1.84%. So if I was charging $2,453.99, I would increase that by 1.84%, and I would now charge roughly $2,500.